notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. As of now, sections 1, 2, and 3, 33 videos and 12 more, and then 6 more. All 51 of those videos have been published in their entirety on YouTube. Please make good use of them. Section 4, measurement. All 17 of these videos have been completed, and 5 of them have been published in their entirety on YouTube. We are now at section 5, statistics. This is the 10th of 17 videos, and I am far behind schedule. After we finish section 5, we will go on to section 6, algebra. And as I said, we are behind schedule. Then section 7, relations, functions, and graphs, followed by section 8, geometry and trigonometry, and finally, section 9, vectors and matrices. Disclaimer, this schedule was just a projection and now has to be adjusted. A reminder that I have divided section 1 into 33 videos. And as I said, all of those videos are published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So 33 videos. Please make sure you look at all of them and know them very well. Another reminder, you need to know the times tables 2 to 12. If you already know those, fine. But if not, you will have to learn them, especially since calculators are not allowed in paper 1. As already stated, all 12 videos from section 2 have been published in their entirety, and all 6 videos from section 3 sets have also been published in their entirety on YouTube. Section 4, measurement. Some of these have been published on YouTube in their entirety. That is, these highlighted in yellow out of the 17 videos, those 5, and then the others are only partially published on YouTube. We are now at section 5, statistics. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2 to get especially more practice questions. CSEC recommends the following books shown on right, these books here, and their authors. Please pay particular attention to these last 2 at this point, since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi. And this is a picture of volume 2. Another disclaimer, I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, that is from paper 2, the structured questions. You can navigate by topics or years, where all questions for the past several years have been worked out for you, that is, questions from paper 2. If you have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely it will be explained to you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. It is extremely important that you know this. The website is located at this URL, and on the next slide, I will show you what the home page looks like. This that you see here is the home page for that website. You will have to register first and then sign in. This is the URL again. That's the home page as of January 16, 2025. This URL will be in the description of this video below so that you could easily click on it and be redirected to that website. Another reminder that for the math exam, CSEC, this formula sheet will be provided. This formula sheet here on the left. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the syllabus, that formula sheet is in the syllabus. This is the first part, the top part of that formula sheet. Keep in mind that you do not need to learn these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of the same formula sheet. And while you don't have to learn these formulae, you do need to know when and how to use them. So statistics, this is a print screen of this part of the syllabus, 5 objectives that we already completed in 7 videos, since this objective required 2 videos and that one 2. Another print screen. Continuing, objective 6, we have completed that. We are now at objective 7, video 10, part B. And then we have to go up to objective 14 in this section. So section 5, statistics, has 14 objectives, which I have divided into 17 videos. We have completed those above there. We are now here, 5.7b, which is video 10. These have been published on YouTube in their entirety, and these others only partially published. Once I finish this video 10, it will also be only partially published. Note that this section is of particular interest, as you will have to make use of many of these concepts and principles for your SBAs. Now, if you are also taking physics, you will have to do a similar profile, which involves analysis and interpretation for one of the SBAs, in collecting data, analyzing that data, often using a graph, line graph or otherwise, and then interpreting and extracting information from that graph. Projection is also required. Now, this does not only apply to physics, but basically any other subject that you have to do SBA for: chemistry, biology, principles of business, social studies, and so on. But not only that, understanding these principles at the foundation of statistics is a necessary and even crucial part of life skills, so that you are not deceived by a one-sided argument using statistics. So you need to know something about statistics for life generally. So as I said, we are here, objective 7, part B. The objective says determine the measures of dispersion for raw, ungrouped data and for group data. We did this in the last video, raw ungrouped data. We need to talk about range, interquartile range, and semi-interquartile range. So as I said, I have divided this objective into 2 videos. Section A measures of dispersion for raw ungrouped data. That was the last video. And now we are at section B, measures of dispersion for grouped data, video 10. So we did that already. We are now here for grouped data. Now recall in the last 3 videos, we were dealing with measures of central tendency, where we talked about mean, median, and mode, and when to use them. Now all 3 of these are averages. And then we also discussed that those are not enough to correctly understand or appreciate a piece of statistical information. We also need to know about measures of dispersion. So in video 9, we covered raw ungrouped data. And now this is video 10. We are going to deal with grouped data. And of course, in video 11, the next video, we will be looking at standard deviation that we touched on before. However, there is something that is a bit confusing about this objective up here. We dealt with raw ungrouped data last video. And this video, we are to deal with grouped data, the range, interquartile range, and semi-interquartile range. And even though I split this objective into 2 parts, it appears that something is missing. Consider the tables on the next slide. This one here, we have raw ungrouped data. That was the last video, and that was section A of this objective. And here we have group data with frequencies. This is considered as section B of this objective, which is video 10. But there seems to be something missing, which is this. This is an intermediate between A and B. That is to say, it is ungrouped, but it is not raw. So A, raw ungrouped data, B, group data, but AB, somewhere between those two, it is ungrouped, but it is not raw. So it is ungrouped, 51, 52, 53. But notice you have frequency here. So some processing has been done on the information in this table in the middle here. And that means that we need to make a decision whether we should include this type of questions in this objective. So to be safe, we will do 2 examples of this AB type, this type here, and then 3 examples of this one over here, just to be on the safe side. So example 1 of the AB type, you have this information on group data here and frequency. First, let's look at range. As we already pointed out from page 65 in your mathematics syllabus, we have a definition for range. So let's see that closer. The range of a set of numbers is the difference between the largest value in the set and the smallest value in the set. Note that range is a single number, not many numbers. But that definition holds true for raw ungrouped data. What we have here is ungrouped, but it is not raw. So we will have to modify that definition a little, and we would say that the range is the difference between the upper boundary of the largest value and the lower boundary of the smallest value in the dataset. So that would be 60.5 minus 50.5. That is to say, since we are going in 10, 58, 59, 60, this would have been 61. So halfway between 60 and 61 is 60.5. And down here, what would have come before 51 is 50. So halfway between 50 and 51 is 50.5. So we are using the boundaries. And that gives us 10 kilograms. That's the range. Note, it is not 60 minus 51. Because we see a 51 here and we see a 60 here, we may be tempted to say 60 minus 51. No, that would give us 9 kilograms. It is the boundary we are using. So the range is 10 kilograms. Now let's talk about the interquartile range. This is the difference between the first and the third quartiles. First, we will construct a cumulative frequency table. We know how to do that. We have met it before. This 10 goes over here. Take that 10, add it to that 12, and you get 22. 22 plus 15 gives us 37, plus 17 gives us 54, and so on. So we have the frequency being accumulated here. So we have cumulative frequency. We will find Q2, which is half of n plus 1, but that will give us a rank. That would give us the second quartile. N in this case is 150. So we will add 50 and 1 and find half of that. That will give us the position of Q2, not Q2 itself, just the position of Q2. We do the same thing for Q1. N plus 1 multiplied by a quarter. That will give us the position of the first quartile. And then for the third quartile, n plus 1 multiplied by 3/4, that will give us the position of the third quartile, not the actual number, just the position. So for very large frequencies, we can ignore the plus 1 in the above expression. It's plus 1 here, and there, and there. We can ignore those. Keep in mind that these numbers here are in ascending order. Normally, we would have the lowest number down here and the highest number up here, so it would be in descending order. But now, these numbers are in ascending order. So let's find the first quartile, which is quarter of n plus 1. That's a rank. So when we find quarter of 150 plus 1, we get 37.75. That's a rank. We need to locate the number at that position. So if you were counting, if we count all the 51, 10 of those, we will get 10. And if we count the 52s, 12 of those, we will now have a total of 22. And if we count the 53, 15 of those, we will have a total of 37. But we haven't reached Q1 because Q1 is 37.75. So we have to start counting the 54. The first 54 would give us 38. But we don't want to go to 38. We want somewhere between 37 and 38. So what we will have to do is find the mean of 53 and 54, and that gives us 53.5. So Q1 is 53.5. The position of Q1 is 37.75. The actual value for Q1 is 53.5 kilograms. That's Q1. So as I said, if you were to count all the 51s, 10 of those, you will arrive here. And then you go on to 52, 12 of those, 52, 12 of those, you will arrive at 22, but we have finished with all the 52s. Then we start counting at 53, 15 of those, 53, 15 of those, we will arrive at 37. So let's look at the next slide to see this better. Let's write down all the numbers, all 150 of these numbers. Because remember, you have 10 51s. So we count 10 51s and we arrive at this point, 10 51s. Then we go on to count the 52s. We have 12 of those and we arrive at 22 cumulative frequency. Then we start counting at 53, which is here. 15 of those, 15 of those, and we arrive at 37, which is here. Now remember, we want to go to 37.75. So we haven't reached there yet. But if we start counting this 54, the very first 54 will take us to 38. If we were to count all the 54s, we would come down here to actually the 54th position. But we don't want to go to 54th position. We just want to go a little past 37. So it must be somewhere between here, between 53 and 54. So the rank or the position is a little past 37, but it hasn't reached 38. So it has to be somewhere between 37 and 38. And therefore, we will find the mean of 53 and 54. This, not the 37 and 38. That just gives you the location. And that is 53.5. That is a Q1. We will return to this expanded list to find Q3 shortly. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. So that is how we got 53.5. So we got Q1 is located at this position, and the number there is 53.5. Now, if we do the same thing for Q3, 3/4 of n plus 1, to get the third quartile, we will find the position at 113.25. That is to say, if we were to add all the 55s, we will arrive at 74 total. All the 56, we will arrive at 99. We still haven't reached 113 yet. But then when we start counting the 57s, if we were to count all the 57s, we will arrive at 115. So that's a little over where we want to find. And that will be 57 kilograms. So let's return to this table for Q3 so you could understand it clearer. We want to go to this position. So if we count all the 55s as well, we will arrive at 74. We haven't reached 113 yet. If we count all the 56, we will arrive at 99. That's down here. We haven't reached 113 yet. If we count all the 57s, 16 of them, we will arrive at 115. Here. Notice we have passed 113. So 113 position would be somewhere between this 113 and 114. That's somewhere between here. But then we have the same 57 here twice. So if we add 57 twice and divide by 2, we will still get back 57. So Q3 is 57. Now I hope you understand that, because in the next example, I will not go through this expanded version. So I hope you understand the difference between the rank or the position and the actual number that is there. So now that we have Q3 is 57 kilograms and we have Q1 as 53.5 kilograms, the difference between these quartiles, the first and the third quartile, is the interquartile range. So finally, we will subtract Q1 from Q3 and we get 3.5 kilograms for the interquartile range. As I said, we are not really interested in the second quartile or the median.